Good morning, my dear students.
There are two types of discharge breakdown, external breakdown and internal breakdown. And coming to the fourth one, electrochemical breakdown. It is similar to thermal breakdown. When the temperature of the insulating material is increased, chemical deterioration takes place. The mobility of ions increases and thereby electrochemical reaction takes place. Leakage current increases and leads to dielectric breakdown, which is known as electrochemical breakdown. The characteristics of this are: number one, determined by leakage current, density of ions, temperature, and permanent dipoles in the material. Second one, it is accelerated by temperature. Third one, to avoid electrochemical breakdown, impurities should not be mixed with the pure dielectric materials. And fifth one, defect breakdown. If the surface of the dielectric material has defects such as cracks and porosity, then impurities such as dust or moisture collected at these discontinuities, leading to defect breakdown. Characteristics: if the defect is in the form of strain inside the material, then that region will break down on applying a small electric field. Next, let us understand what is electrostriction. It's a phenomenon of polarization of a dielectric in an external field, giving rise to the presence of mechanical forces in the dielectric. That means mechanical forces and stress will be developed within the dielectric due to the applied external field. The dielectric experiences a pressure given by the relation P. So here P is not polarization, P is pressure. It is given by epsilon naught into epsilon r E square by 2. You know all the terms. The mechanical forces in a dielectric placed in an electric field of high intensity are large. Therefore, tends to deform the dielectric material because of very large force. The nature of deformation depends on the permittivity of the dielectric with respect to its density. Within bracket, we have written d epsilon by dp, d rho. That means rate of change of permittivity with respect to density of the material. If permittivity increases, that is d epsilon by d rho is greater than 0, the dielectric material tends to reduce its volume. Hence, all dielectrics compresses when the electric field is applied. The mechanical deformation of a dielectric material induced by an external electric field is known as electrostriction. However, in an alternating electric field, the dielectric slab vibrates vigorously at high frequency because of electrostriction. Effect, and thus produces high frequency ultrasonics in a piezoelectric oscillator. That is the application part of electrostriction. Next, let's understand what are electrades. Electrades. An electrade is a dielectric with QZ permanent charges. That means they possess plus and minus charges and they have dipole moment. They behave as electric dipoles, permanent dipoles, and such devices we call them as electrades. The charges may be surface charges, space charges, or it may be due to orientation of the dipoles. Methods of making electrades. Methods of preparation. Number one, thermal method. The material is heated to sufficiently high temperature under the applied electric field. For example, waxes are taken above the melting point and subjected to electric fields of several hundreds of kilovolts per centimeter and kept under these conditions for some time. The temperature is then gradually reduced. The temperature T at which the material has to be kept for minimum time to acquire maximum polarization is called polarization temperature. So at this temperature, the material becomes dielectric and we call it as electrate. And the second method is accelerated charges. Accelerated electrons are allowed to fall on the surface of the material. The rear side of the specimen is generally metallized. At the surface, they release some secondary particles, making the surface positively charged. That means negatively charged electrons will be leaving the surface, thereby the surface becomes positively charged. On entering the body of the specimen, they produce electron hole pairs which get trapped inside the dielectric. UV rays or even visible light can also be used instead of charged particles to prepare the electrate. Such electrates are called photoelectrates. These materials are known as photoelectrates. Photons produce charge carriers which move in the applied electric field and ultimately gets trapped. Example for photoelectrate are cadmium sulfate, anthracene. They are used in making solar cells, solar panels. Since the charges on the electrates may arise from dipole orientations, trapping of charges or charge building up near heterogenetics such as grain boundaries in polycrystalline materials. Some examples of electrates: polyethylene, terephthalate, mylar, Teflon. I think you heard about Teflon coating. Carnauba wax, anthracene. Some electrates are also piezoelectric in nature. Example, polyvinylidene fluoride, PVDF. All these have low electrical conductivity. Teflon has conductivity of 10 power minus 24 Siemens per meter compared to 10 power minus 16 Siemens per meter of quartz. Applications of electrates: electrate microscopes used over wide range of frequency, hundreds of megahertz with low noise. In making microphones, we make use of some electrates. They avoid noise and produces sinusoidal waves of several hundreds of megahertz. That means radio waves can be generated. Electrate are also used in hearing aids, used to detect air pollution, reaction kinetics of gases, used in electromechanical transducers such as phonograph cartridges and relays. Transducer means they convert one form of energy into another without altering the information. They are called transducer. Even microphone is a transducer, loudspeaker is a transducer. Fifth application, electrete filters are used for removing submicroparticles from polluted gases. And sixth application, used in healing process of fractured bones. These are some applications of electrates. And they may ask you small question, 2 marks question on these. And finally, piezoelectric effect. Piezoelectric effect is a phenomenon exhibited by certain dielectrics. The phenomenon in which the ferroelectric material or dielectric material like quartz become electrically polarized when mechanical stress is applied is known as piezoelectric effect. The phenomenon of deformation of the crystal under the action of electric field is known as inverse piezoelectric effect. That means when you apply electric field, the material contracts. That is because of piezoelectric effect. That is because of electrostriction effect, and we call it as piezoelectric effect. The polarization of the dielectric as a result of mechanical deformation is called direct piezoelectric effect. If an alternating voltage is applied between the two opposite faces of a crystal like quartz or tourmaline, it vibrates with the frequency of the applied field due to contraction and elongation of the crystal. The frequency of vibration depends on the dimensions and elastic constants of the material. The piezoelectric oscillator uses this phenomenon to generate high-frequency ultrasonics, which are used in medical physiotherapy centers for reducing pain in muscles and joints, and also for dilation of blood vessels. Applications. Some of the applications of piezoelectric effect. We can go through this list. Pyroelectric materials are used to make very good infrared detectors which can operate at room temperature. Materials such as TGS, Na, NO2 and PZT ceramics are used in the construction of pyroelectric image tubes. The inverse piezoelectric effect is utilized in quartz watches which keep accurate time. It can be used to induce violent agitation of the liquids in the tank of an ultrasonic cleaner. Ultrasonic cleaners are also used for cleaning semiconductor wafers in the semiconductor device fabrication. The direct piezoelectric effect is used in phonograph pickups, microphones, piezoelectric compression, accelerometers, gas lighters, etc. Seventh application, piezoelectric materials can be used as oscillators. And eighth one, piezoelectric materials such as quartz are used in band pass filters in communication field and telephone industries. Ninth one, piezoelectric materials used as transducer measures pressure very accurately. As you know, transducer, it converts any mechanical vibrations due to pressure changes into electrical signal without altering the frequency. For example, microphone is a transducer. 10th application, dielectrics have several applications. Polymers and ceramics are the widely used solid insulators. A variety of plastics, rubbers, waxes, paper, synthetic fibers, and fabrics are applied in the form of films, sheets, slabs, tapes, sleeving, tubing, rods, and molding. 11th one, porcelain towers are used in high voltage power lines because of their high dielectric strength. 12th one, petroleum oils and silicone oils are mainly used as filling medium for transformers, circuit breakers, etc., and as impregnants for high voltage cables. 13th application, cooking in microwave oven is one of the popular examples of dielectric heating. Fourth one, dielectric heating is widely employed in dehydration of fluid, food, tobacco, etc. And 15th one, wooden sheets are glued by dielectric heating. So these are some applications. Any 2 marks question asked on application part related to piezoelectric effect, electrostriction, or even electrates, you must be able to answer. This completes the content of dielectrics. Please go through the notes thoroughly and work out all the derivation part clearly. If the steps are not clear, you go through the notes, it will be clear. And any doubts, you are most welcome to ask. I will take one more session to work out problems on dielectrics that will complete dielectrics chapter. So remaining one more chapter, elementary particles, I am halfway down, and the remaining portion will be completed in the next session. Thank you all. Wish you all good luck.